Oh, I'm Glenn, WB3GM.
Ned, WQ3Z, how am I making the machine?
Dennis K3DS.
David K3DMH. I'm M3 JIZ.
Karen, JC3AC.
Everyone, KC3ACL.
Yep, WA3RIZ.
I'm Jeremy and I'm new.
Well,
Yeah.
We like to do
I'm Jesse, KC3YBW.
almost there.
it.
Worried about the.
All right, why don't we go through the reports or a quick little,
Yeah, I didn't get a chance to do the reports, but basically we have
money?
money, I mean, 5 figures worth of money.
Wow.
Oh,
What is the part?
And we're up to like 40 some people.
40 people already, but we want to get up into the 80s.
That's right.
That's where we like
Well,
to
we'd
be.
love to be at 100 again. but
Well,
that's-
that would be nice too. So if anybody hasn't paid their dues, Lou's here,
Yeah.
so.
Yeah.
Okay, Dennis,
Yes.
you have anything to share with the
These are
technical?
Operational, except I wish more people would use them because they are all operational. In fact, just coming over here this evening, our Paoli fusion machine is hooked up to Keystone Y, which is supposed to be a network. They're trying to.
Yeah.
promote. It's about 85% in western Pennsylvania. But this fellow was on the Reading repeater, which is getting closer to us, right?
yeah.
And he was in Morgan.
Next day, you
Oh,
He was in
okay.
Morgantown, fusion. So he was going through Reading, through the internet, over to actually our computer, to my PDM at home, to then fix up my mobile rig to my house, goes back to the internet. It's a wonderful world. So that's the.
Okay, thank you, Dennis. Bob, you have anything to say? I know it's a little early, but
We're just waiting for the weather to break to do the speaker installation at the firehouse at the Kimberton Fire Company firehouse. A building, whatever it's called, and we're gonna get hopefully we'll start to get the Hamfest flyers together soon and get the schedule of Hamfest. So we need to deliver the Hamfest flyers to together also. That's the next thing, I guess, and of course Hamfest is second Sunday in August.
that's the 10th.
Ten.
Can't come soon enough. So, good. All right, anything else?
I think that's it.
Ned, would you like to say just a quick breakfast thing?
Oh, we had a great time at breakfast.
Yes.
The next MARC January QSO breakfast will be February 25th, Saturday. I'm sorry, February 22nd, 9 AM at Andy's Diner on Ridge Pike in just outside of Conshohocken. And if you're heard on the repeater and you've never been to a MARC January QSO breakfast, it's breakfast on cue.
So that's motivation to get a free breakfast.
Yes.
Breakfast.
We had 2 new people this month at the last breakfast.
Yeah.
So Ned's gonna be broke.
Well,
They were on the repeat.
in this case, they weren't here to repeat, but they owe me a check into the net.
Oh, okay. So they owe you one. Okay, and I'll just say a quick Hamfest, not Hamfest. Field day. That's coming. I'll have to get with Lou. Lou, can we get the site? Look into
I'll have
it.
to check.
Thank you.
Yes.
So that's coming obviously in June. The other thing is public service events. I'm pretty sure the first one's gonna be in April. I still haven't got confirmation from the organizers yet, and there's nothing online, so it's kind of crazy, but other than that. Anything else?
Which one is that now?
It's normally Penwinish over in that, it's over right off the City Line
And
Avenue.
when-ish.
And win it's at the school.
Okay.
Yeah, it's close. to-
Yeah, no, I just wondered what the event was.
It's a 5K, I'm
Okay,
sorry,
okay.
yeah, 5K run.
Do you want my report on what didn't happen this past year?
Yes, with
Yeah, the what are they called?
the Vietnam veterans.
Vietnam Veterans
Memorial Run.
Memorial Run. It's normally in November. The organizer passed away a couple of years ago.
Right,
And it just sort of went like nowhere for a while. The current leader of the organization tried to get it going this year. He did not ask for our help. I kept offering it to him. He didn't ask for it. He said that they didn't make any money, so I don't know if it's gonna happen next year or not, this year or not, so.
well, hopefully it does, we'll look forward to it.
Yeah, and I'll, he's at the same, one of the firehouses that I'm also at, so I'm sure I'll hear about it if he tries it again, so.
Very good.
Yeah.
Okay, let me just see if Jeremy,
There's two bells.
are you there?
Yeah, I'm here.
Okay, do you have anything you want me to
Nothing to
relay?
add.
Because it's kind of hard to hear on.
Yeah,
Okay.
nothing to
Well,
add.
Okay, we're gonna start with Lou, so you want to crank it up?
All right.
Is it?
Yeah, we're good. We're on YouTube. We're good to go.
Yeah, let's
So it looks backwards here, it's not backwards on.
Is it started? Is it started just smoking?
Where you have it set.
I hope it's not that. You ready, Jeremy? You good?
Yes, everything's good.
Let
We're
me,
good to go.
let me get, all right, Lou.
Okay, all right, so this has been billed as advanced Skyward. Right now, National Weather Service is not doing Skyward.
That's since January 20th.
What's that?
That's since January 20th.
Well, I think that has something to do with it. So anyway, yeah, so I'm calling this advanced not Skyward. And it's not from the National Weather Service.
You probably need to say, keep passing back.
Well, where is the mic?
I
I don't know. Can you hear me, Jeremy, or do I have to stand closer?
No, we can hear you fine.
Okay, all right, sounds good.
Huh?
All right, so anyway, I'm gonna try not to make a big deal of it, but basically, this is not real. This is the Skyward presentation, but we can't call it Skyward, so. At any rate, here's what we're gonna cover. Oops. There we go. And actually, once they do start Skyward training again, which I think they will, we do recommend that you take the basic Skyward. This is not basic Skyward. We're not gonna talk about reporting and that kind of stuff in this class. So I know Michael still doesn't know how to report, but we'll fix that. Okay. Anyway, I keep hitting the wrong button, sorry. Okay, so these are basically the four topics we're gonna cover, some radar concepts, satellite concepts. A little bit on soundings, which probably most people don't even know what I mean when I say soundings. But hopefully you will at the end of this, and then also a couple of case studies. All right, so we're gonna dive in radar basics. Everybody's familiar with basically radar, which is this dish that's on.
Could you stand on, perhaps on the other side, because you're.
Well, but the laptop's here, so
Oh, that's not the one.
no, this is.
You want to sit over here, Michael? I can, yeah, come around, get here.
Where's the chair push? Were you?
I'm just gonna hang right over here. I'm good. Sure.
Okay, so anyway, hopefully everybody's familiar with basically radar. Radar is in fact, I probably have I know I have the acronym in another slide, but basically, you have this big dish, which is putting out radio waves, okay? And it's also listening for radio wave reflections, not yet. We have a little tennis ball thing that we're gonna do. So anyway, so everybody's probably familiar with that, but that is one of the big and best tools for tracking the weather, is this weather radar. The current radar is called WSR-88D. You might also hear the term NEXRAD, but basically the reason it's 88D was it was actually like started to deploy in 1988. most of the things were deployed in 1990. Or, well, in the early 1990s. There's also some other things. There's what they call terminal Dopplers, which are smaller radars on a different band, which are associated with airports. That's what TDWR is up there on the slide. And well, the other thing that happened back in 2011, around 2011, 2013, the radars got updated with what they call dual polarity. And dual polarity is what the radar is sending out a vertically polarized signal and then very quickly a horizontally polarized signal. Okay, and that gives all sorts of things that help figure out what the weather is. So, and we'll go through all of that. Okay, let's see if this works. Let's see. Yep. So, in case you, I mean, it was real quick, they sped it up really good. But that thing over there on the right, which is what you'll see when you look at the radar, it's that big golf ball thing is the radar. And inside it is the actual dish that's spinning around. So,
How big was that dish?
I forget. But you can see the dish spinning around. It doesn't spin around that fast, it's actually slower, but but what that dish is doing is basically emitting those two pulses, the vertically polarized, horizontally polarized, and then listening for what bounces back to it when it hits rain or hail or bugs or birds or whatever it hits. It'll bounce back at the radar. And that's what it's listening for. So it sends out these really quick pulses and then listens, and it's just spinning the whole time. So, but at any rate, that's what the radar is. The next rad radars, the 88Ds, are the ones that do dual polarity. Most of the others do not. So they're only emitting a single pulse. So you can see that there, horizontal and vertically polarized pulse. And hopefully everybody can see that. The thing on the right there is where all of the next rads, the 88Ds, are deployed.
How come there are holes?
What's that?
Why are there holes?
Because they don't have units there, and that's coverage up to 10,000 feet. Sorry, 10,000 feet above ground level. A lot of the weather actually happens much lower than that. So that's the other thing. It's like some of those, when you get further away from the radar, you're really seeing what's happening close to the ground, which is another issue.
The surprising one is in the Pacific Northwest there.
What's that?
Yeah, the other ones look like they come from all the population.
I don't care about the middle of the White Sands or something, but the Pacific
Yeah.
Northwest one is pretty big.
Yeah. Yeah, one of the things you may notice is right here, which is like really close to us, there's a hole. Okay. And the other thing that's happening, not really well organized, because it's a company that's doing it. So basically they're trying to make money doing this. So they're not deploying things where you think they might make sense necessarily. But one of the ones that's recently been deployed is at Millersville University, which I think Channel 6 is actually displaying it on their radars, and I think they call it Lancaster, but I think it's Millersville University. The trick with that one is, again, it's a different kind of radar. So you got the 88Ds, which I think are, they call it C-band, I think. Okay. The terminal Dopplers are a different band, and then these ones that this company is deploying, and then like the one at Millersville, is X-band. And X-band is around 10 gigahertz, I think. Okay.
It starts at.
Right. And as we all know about RF, the higher the frequency, the more of a problem you have with attenuation of the signal. Okay. So the X-band radar is actually, like on a rainy day, that Millersville radar is not going to go very far, because the rain's gonna be reflecting back to it, and it's gonna get accumulated. But anyway, I digress.
Is that a hole on the east coast there? Is that over Green Bank? Was it West Virginia, the quiet zone?
Good question. That looks like you mean this one right here?
Yeah.
Yeah, I mean, that's Virginia is where it is. That's Western Virginia as opposed to West Virginia. So is that a known quiet zone? I mean, I don't think these were deployed with that in mind. I mean, it was really, yeah, where can they get a tower to put it on and, all that stuff, it was a big effort getting this up. But as you can see, I mean, there's like, and I've been in this hole up here in Montana, around Montana and North Dakota, and there's a big hole there. Makes it fun going storm chasing when you can't see anything. But anyway, any other questions before we move? Okay. So here's it's trying to show you the dual pole radars, but basically what's happening is that dish is spinning around, as you can see in that video, and it's emitting those pulses. If those pulses hit rain or hail or snow, and like I said, birds and bugs and all sorts of stuff, some of that radio signal is going to get bounced back, and that's what the thing is listening for. They actually, when they issue this, they actually, the radar dish will spin like this, then they'll raise it up a little bit and spin it again and raise it up a little bit more and spin it again. And what they call that is a volume scan. So you're actually not just looking at what's close to the ground, but also looking at what's above the ground. And that way you can get, like if there's a really impressive looking thunderstorm, you can actually get a real good picture of what the thunderstorm looks like by doing it. And like it says there, a complete scan is normally going to take 4 to 5 minutes. It really depends on what they're doing with the scan pattern. Because sometimes they don't go up as high, sometimes they'll stay lower and all that stuff. They can do that quicker. So anyway. Okay. So some of the products that you get out of the radar, there's the reflectivity. The reflectivity is just, okay, what, I got an echo, it came back and it was real strong, or it was weak or whatever. And basically that gets plotted on a color scale. And it'll look something like that. You've probably all seen that on the internet. And generally, you can use any color scale you want. Most color scales, the red is heavier. Purple is really bad, green and yellow and that kind of stuff is like, okay. But you'll basically see that there when it gets plotted. But that just tells you that something's there, okay? And like I said, it could be rain, it could be hail, it could be birds, it could be bugs. I keep saying that, I'll probably say that a bunch of times. But so another thing, they are Doppler units, so they actually can measure velocity of what bounces back. Okay, so typically when you get the velocity, you plot it on that same map, but you plot it with a different color scale, and it's basically showing the velocity. It's showing the velocity of what's coming towards the radar and also what's going away from the radar. So, same thing as when a police officer aims a radar gun at you, it'll tell them what speed you're doing, even if you're going away from it, because it computes all. So, so anyway, that's good for detecting some things that, obviously the reflectivity doesn't get you, but it's good for just seeing how the wind is flowing. And also if there's like a low level jet, which means a stronger wind current that's close to the ground, is called a low level jet. There's another thing called storm relative velocity, and that's basically that previous plot, but then you also, how, like if there's a storm there, you know how fast the storm is moving. So you subtract the speed of the storm out of it. And so you actually get what's happening in the storm rather than what you're seeing at the radar. Okay.
How do you get the speed of this?
Well, it says it right there. User controlled storm motion. So basically, they actually basically say, based on like what they're seeing visually, they will estimate the storm motion. And-
Okay, so that's a,
Yeah.
that's not from the radar per se.
No,
It's a,
that's a parameter that you put in there, yeah.
put it in. Okay.
So between the radar and then also what you're seeing on the satellite and that kind of stuff, you
Well, yeah,
can,
because the wind's going around.
Yeah.
This one's going away from you, this one's coming toward you.
well, that's when you're seeing rotation, but I mean, basically,
That's
the overall storm motion is not so much the rotation, it's the
Right.
speed of the parent storm, yes. So you're right, yeah, when you subtract out the storm motion, then you get a better idea if there's any rotation. Yep. That's almost what, when I'm looking at stuff, I'm almost always looking at storm relative stuff. So anyway. Correlation coefficient, those first three that I read to you were really had nothing to do with the dual polarity stuff. This one is dual polarity, and it's called the correlation coefficient. Correlation coefficient is basically, you know, how close, let's see, how uniform the thing that you're hitting, they call it a hydrometeor, how uniform it is, okay? So you get this thing goes this way and this thing goes this way. And if both of them, what reflects back is really close to each other, then the correlation coefficient is close to 1, okay? For all the precipitation types, the correlation coefficient is going to be close to 1. And then when you get to big hail, it might be a little bit less than 1. When you get to things like birds and bugs and that kind of stuff, it's really low, because it's just a big haphazard mash of stuff that's out there. So one of the ways, and we'll cover this later, but you'll probably hear it on TV. They talk about, you can see the debris on the radar. Basically, if you have a tornado going through, you'll see this really low correlation coefficient if it's picking up debris. Okay, so you'll see that.
For the correlation coefficient, are you correlating the readings from the nearly simultaneously transmitted pulses, or between from pulse group to pulse group?
It's the simultaneous pulses is what you're looking at, yes.
Okay.
Okay. Therefore, differential reflectivity test, this is also a dual pole thing, and basically, if the vertical pulse has a different reflectivity than the horizontal pulse, then you'll get a ZDR. And ZDR is one of the key things that ZDR is used for. If there's really big hail, your ZDR is going to be really close to 0, because what actually happens with big hail is it's spinning as it's falling. So basically, you don't really see any difference between the reflectivity. You just see this thing that's falling. So vertically integrated liquid, that's actually not dual polarity. That's one that's been around for a long time. But it's basically an estimate of how much liquid is in the column. So when they're doing these volume scans, they're getting, you know, a reading of a column. And if there's echoes all the way up the column, then your bill is going to be real high, and if there's not, it's going to be lower. And how strong they are. It's actually computed, and I don't really know a lot about it. But basically, it's also another parameter that tells you there's a good chance that hail is either happening or going to happen. So.
What would be the characteristic for a hailstorm?
Well, I'm not sure I can give you a simple answer, but basically, if there's a lot of moisture in a very tall part of the part of the storm, part of the column, that means that there's that much more, um. There's a lot of moisture, which is basically, once it gets above the freezing layer, it's gonna freeze, and that's what how you're gonna get hit.
Oh, okay, so it's an inference based on.
Yeah.
Yeah.
Mhm.
I got it.
Okay, radar estimated precipitation, again, based on what the radar is getting, they actually compute how much precipitation was being seen in a certain place. Also not a dual polarity thing, they've been doing this for years. The estimates sometimes are good and sometimes aren't, because it depends on how far away from the radar, what it's reflecting off of, and that kind of stuff, so. Okay, so a couple of radar signatures, which, you know, even they've been looking at this stuff for years, and even before dual polarity, one of the things that they always look for was something called a hook echo. Okay, and actually and that's in the reflectivity. Remember the reflectivity scan, which is just, you know, whatever bounces back. You actually see this, the moisture start to wrap around the center of the storm. And what's causing that to wrap around there is basically rotation. So that used to be the way they could tell if there was a chance of a tornado, because they were looking for a hook echo. And if they saw a hook echo, they'd say maybe there's a tornado.
Is that a picture of it?
Yeah,
Where's the hook?
that's the hook right there.
Oh, I would have said the other side.
Yes. Okay. Sometimes it's more pronounced than that. In fact, sometimes you actually see it really wrap around, but in this case, it's not real strong around it. But yeah, that's actually from 2021, I believe it was. There was a big tornado outbreak in the Ben Salem tornado. Remember the Ben Salem tornado that destroyed the what's the name of the car dealership? There's a car dealership right up there that basically their service area got blown away. What's that?
They were one down.
Yeah.
In the hook echo, I was under the impression that movement towards you was one color, movement called parallel to you would be another, and then movement away from you was a different color.
Well.
I-
Okay,
Maybe it's because we're outside.
remember, we're looking at reflectivity. Reflectivity is not measuring motion, okay? We're looking at the storm relative motion, or the storm relative velocity, or the straight velocity scan. Then yes, what's moving towards, it's always in relation to the radar unit, okay? So if you see stuff moving towards the radar, it's in the green area. Moving away from the radar is in the red area. Okay, and it depends on what color scale you're doing. Generally, that's what they do. But that's, you only see what's moving towards the radar away from the radar. But if it's rotating, you're going to see that in a really close-knit blob that basically shows that.
So maybe it's the distance.
But this is reflectivity. This is
So
not,
I won't see it there.
you won't see it there. No.
Gotcha, okay.
But before the 88Ds, they were not doing Doppler. So this is how they figured out if there was a chance of a tornado. So, okay. QLCS, I don't know, has anybody ever heard the term QLCS? I use it a lot, but you used to hear people call things a squall line, okay, which was a line of thunderstorms. Well, QLCS is basically a squall line, but it's really well organized. So this picture here is a squall line. The key with the QLCS system is what happens is that's where you get the bow echoes. Everybody's ever heard the term of bow echo. Basically, if you look on reflectivity, you see part of the line that's pushing out ahead of the straight line. That's called a bow echo. Okay, that's usually stronger winds. The other thing is when you get these areas that are pushing out, on either end of the area that pushes out, you'll see a little kink in the line. And a lot of times there's rotation that happens there, so you can get a tornado here. Most of our tornadoes around here tend to be fired off by QLCS systems.
That's a fairly common way that we get storm, though, isn't it? It's
Yeah.
small on business here.
Yeah.
Is that just a regional thing, like, you know, based on the fact that you're near the ocean or something like that?
Well, I mean, yeah, it's a combination of things, all the factors that tend to form supercell tornadoes, which is based like the hook echo is usually gonna happen in what's called a supercell tornado, which is it's a big storm, but it's really sort of isolated, it's not really, you know, completely in a line, it's basically sort of a little bit out by itself. And the hook echoes are actually real common in supercell tornadoes, and they're not real common in QLCS. So QLCS, you're looking for the little kinks in the line rather than the actual hook.
In the regions of the world, right, it's well known, you know, Midwest is tornado valley, right? Is that because of the flatness, right? There's no other region that suffer like that?
It's not the flatness, I mean, that's one of the things that people say, but it's the fact that there's a lot of factors involved in it. One of them is the fact that you have the mountains to the west. So you actually get what's called an elevated mix layer. Okay, that comes off the mountains. You get moisture coming up from the Gulf of Mexico, from the Gulf of America. Yes. I'm still gonna call it the Gulf of Mexico.
Me too.
But you get that moisture, you get really sort of like really warm air coming off of Mexico. You know, you get that, some of the things you do get, you know, all sorts of.
But you don't see tornadoes in the Sahara that is flat, right?
Well, I mean, you can see tornadoes anywhere. The actual strong supercell tornadoes, basically, the more of those factors that I just mentioned occur, the bigger your chances. But that Penn Salem tornado, which was, I'm gonna remember that car dealer at some point.
Yeah, I'm trying to think.
Yeah, right, but that was, what's that?
Read and told maybe.
No. Yeah, it'll come to me, but basically, those tornadoes were actually those thunderstorms were supercell thunderstorms that day. That was actually a supercell outbreak, but that's pretty rare. The other thing we get here, which you don't get like in Oklahoma, is we get tornadoes that are swung by hurricanes. And we probably get more of those than we do QLCS, but you know, they all come in bunches, so you don't really think of them as much. But if you remember 2020, I got the years all messed up, but the tornadoes that happened with Hurricane Ida. You know, I mean, they were just crazy. I mean, we had 8 of them, I think, out of Hurricane Ida. You know, so you know, they happen.
You know, I lived in Africa. We used to see, especially driving cross country, there's not always some taking roads, nice, but still dirt. You'd see dirt devils that would go fly high,
Yeah.
clear sky.
Mhm.
You know, that's the middle,
Yeah, dust devils usually aren't gonna happen with a clear sky, not always,
Yeah.
but, you know.
but they were harmless.
But yeah, and what. See, you'll see things spinning all the time in the atmosphere, but usually they're really weak. Dust devils tend to be weaker, although some of them can get pretty strong. But yeah, the strongest tornadoes you're gonna see typically come out of supercells. Yeah, because it's big, it's a big high thing, so the rotation goes real high, and everything else. It's that, those are the biggest ones, so we're lucky we don't get a lot of supercells. Because we get a lot of big tornadoes, which is not a good thing.
Now, cyclones are water phenomena.
Well, cyclone is actually, that's an overused term, it's used for many different things, because like in the Pacific. South Pacific, they call, what we call a hurricane, they call a cyclone. A cyclone really is a low pressure system, it is generally what you use. So, you know, so if someone calls well, I know there's super typhoons and all that stuff, but anyway, yeah, cyclone basically just means it's a low pressure system. Okay, here we go. Where's our radar dish? You ready? Okay. No, come on up here. Okay.
Oh, you didn't
There's a new radar called a three-body scatter spike. Some people might hear people call it a hail spike. Okay. And we're gonna demonstrate real quickly what happens with the radar that causes this. So if you look at this radar picture, you have this really strong reflectivity here, whatever color it is. I'm colorblind, but what is that, purple, blue, or whatever it is? Okay. So that's basically, that's big hail. And the other reason that you know really pretty conclusively that it's big hail is that you have this spike coming out of the backside of the okay. See that spike? You see the radar is over here. Okay. And that spike is always going to come away from the radar. Okay. And I'm going to show you why that comes away from the radar. So he's going to be a radar dish. I'm not going to ask him to spin around unless you really want to. Okay. So throw the ball at me. And I'm a piece of hail. Okay. So normally if I'm a small piece of hail, that's what happens. Now throw it again, and I'm a big piece of hail. There you go. So you saw what happened there. I'm a big piece of hail, so a lot of what happened, because I'm spinning and everything else, a lot of what happened actually, it got reflected to the ground, back up to me again, and then back to you. Okay. Now, because that takes longer, that's why you get that big long spike. Okay.
It looks like it's far away.
Yeah, exactly. Yeah, it takes longer to get to the radar. The radar thinks what's happened was further away. So that's why it gets plotted as a spike. Thank you.
So that's really kind of like not a false image, but deceptive, thank you.
Yeah,
Deceptive,
so
deceptive.
there are a lot of, they call them anomalous propagation things. That's one of them.
Just to make sure I understand that. The hail is not in that spike, the hail is actually in the middle of the storm,
Right.
but it's the radar that interprets it that way.
Right, the hail's here, okay, the radar hits the hail bounces enough of the radio signal to the ground. The ground bounces it back up to where the hail is again, and then goes back to the radar, so that takes longer. The radar thinks it's further away, so it draws this thing like that, okay? That makes sense to everybody?
Yeah, I mean, that's really the second thing, you gotta really be able to interpret it.
Yeah, I mean, the good news is it's usually, like that spike doesn't look real strong, and they never do because, it's not. Yeah.
Does modern radar use software to get rid of those things and actually give you the real picture?
Well,
Is that happening?
it does, but these kinds of things probably are still gonna make it through. But if it's in an area where it knows that there's like a building, and that's always gonna reflect back, and it'll filter that in.
We'll just do it with AI.
What's that?
We'll just do it with.
Yeah, AI will fix it.
So, when the guys are, meteorologists are looking at this data on their screens, do they have, even if it's not doing full interpretation, do they have stuff like AI that's saying, this looks like, pay attention here, or an arrow, or pointing their labels, or?
I mean, not so much AI, but they do have algorithms that are basically, interpreting what's there. I mean, this stuff here, the radar actually has various levels, okay? Level 1 is basically the raw data. Level 2 is data that's gone through some processing. Level 3 is what most of your apps on your phone are going to do, level 3 stuff, which is going through all sorts of interpretation and everything. Okay, those are the three levels I know about. But yeah, so basically at level 3, a lot of processing has been done. So a lot of things are going to get. Level 1, it's exactly what that radar is training. So.
Jeff, I think it's an expert system that they're working on.
Okay. Okay. So thank you for your help. It was great.
Oh,
I have this touchpad right here and I keep hitting the touchpad. So anyway. So there's a picture, there's what I was pointing at, but I think I explained that to everybody, so. Okay. There's another thing called a TDS or a tornado vortex signature. And we were sort of touching on this a little bit earlier. The radar basically has these red and green velocity things. Okay. And there are other colors too, and for colorblind people like me, I get very confused by this. But basically, if you see strong red stuff right next to strong green stuff in a small area, then there's rotation. I mean, that's basically what you're seeing. Okay, if it's close enough to the ground, it's probably a tornado. Okay. The problem is the radar is never really that close to the ground that you can say absolutely it's a tornado, but there's a good chance it's a tornado. And that's what they call it. They call it a TDS or a tornado.
The reason we're not seeing close to the ground is because of the curvature of the earth.
Curvature of the earth, and also these things are up. You saw that tower that it was on, and they don't shoot out a beam at 0 degrees. They shoot out a beam at like 0.5 degrees. Okay, so basically everything is sort of getting you away from the ground, because if the beam was hitting the ground so much, you could just see what the ground, which is not what you're looking for.
Do those mobile radar units, like for channel 6 or whatever, do they really add valuable data in the terms of getting in closer to the storm and being able to keep the radar closer to the ground?
Or is it just good marketing? Well, I mean, the TV ones are probably not that great. They're almost all X-band. Remember I mentioned X-band and the attenuation and all that stuff. So they are good for what's right near where the radar is, but you get further out and things, it's not gonna be that great. There's something called a Doppler on wheels. Okay, which there's a research group that has those. He has some X bands, but he also has some other bands as well. But yeah, they get real close, and because they're real close, they can get much finer resolution on what you're seeing. So the Doppler on wheels, the guy who has the Dopplers on wheels, will take them out real close to where they think a thunderstorm is going to be, and they'll start scanning. Okay, and if a thunderstorm goes through where they're scanning, they will get a really good look at what's happening in the thunderstorm and in the tornado. And the trick is, and have you ever heard the term multi-vortex tornado? Has anybody ever heard that term? I guess it's just us storm chasers. But basically, sometimes you will see a tornado out there and it looks like a bunch of little tornadoes spinning around each other. And that's a multi-vortex tornado. Almost every tornado has little eddies and vortices moving around it because it's hitting the ground. So you got the effect of friction and everything else that's happening. With these radars that are real close, that are doing the research, they can actually see all those little vortices. But you know, people who are actually looking at them don't see them until they're bigger. And if the tornado is not fully condensed, you know, when I say fully condensed, a tornado basically has moisture in it and it's low pressure, so the moisture will actually condense. But sometimes it doesn't condense all the way to the ground. So you can actually see the little vortices easier. This is a total aside, I don't have a slide on it, but the biggest recorded tornado was the El Reno tornado in 2013, May 31st, 2013. That tornado was 2.6 miles wide, and it was not fully condensed. Okay, and it had so many multiple vortices spinning around that thing that people who were out there chasing at it, and they were actually big because the tornado was big, so these vortices are big. People would see the vortices and say that's the tornado, but you know, so people got confused. 3 people lost their lives and everything else. Yeah, it was a mess.
Where was that one?
El Reno, Oklahoma, May 31st, 2013.
With the Weather Channel guy?
Well, the Weather Channel guy got seriously hurt. Bad with names tonight for some reason. Yeah. But yeah, the Weather Channel guy got his vehicle got flipped, but there was a guy named Tim Samaras, who was actually a pretty good friend of mine. He was out with his son and his storm chase partner, and their car, when when you saw pictures of the car afterwards, it didn't look like a car. You know, I mean, you could see wheels on it, that was how you knew it was a car, other than that, it didn't look like a car. So. Anyway, let's get back to more fun things, so anyway. So that's what the tornado vortex signature is. So again, you were mentioning earlier, you have different colors away towards you, and that's in the velocity scan. And the TVS is gonna be where that's happening real close to each other, so. Okay, and actually it's drawn. Sorry, this is one of those slides that did multiple stuff. So you see now it put the arrows. So looking at this, where's the radar? Right down there. So the radar is down here in this corner. So that's stuff that's going away from the radar, and that's in the reds. And this is the stuff going towards the radar, and that's in the greens. And you have to look at the color scale because, and if you're colorblind, you just go, okay. It's okay.
Which had pixelated too.
Yeah. Well, and generally it is. I mean, you know, you got this radar beam spreading out. So when it's real close to the radar, you can't really see lots of pixels and lots of big pixels. But the further away you get, the bigger the pixels get. So, and that one's out in near Lambertville. Okay. Here's a favorite. This is really, for amateur radio guys, you should know this. Everybody knows what a side lobe is, right? Okay. Well, the radar actually has side lobes. I mean, everything, the radio thing has some kind of side lobes. Well, the side lobes can get the radar units confused. Okay. And primarily the confusion happens in the velocity scans, not in the reflectivity scan. Okay. So let's see if I can explain this real well. And we'll go over here just so I can see it better. All right, so okay, so here's your velocity. Okay, and if you look at the velocity scan, you see something real interesting there. Which looks like reds next to greens and everything, and you go, okay, well, that's strong rotation. Okay. What you also have to look at is you have to look and see if there's any reflectivity there, because if there's no reflectivity there, then there's nothing to spin. So it's really just, you know, sort of like it's sort of stuff that's spinning some other different reason. Okay. So if you look at the reflectivity, there's really not much there. There's a little bit, but not much, okay? You look at the correlation coefficient, and that actually does look that the blues generally in correlation coefficient are lower numbers, okay? So if you look at correlation coefficient, you say, well, maybe there is some things there. There probably are some birds and bugs and stuff flying around, you know, who knows? Spectrum width, we didn't talk about, we're not going to talk about. But yeah, so there's your reflectivity. Your velocity scan shows what looks like rotation, but your reflectivity really doesn't show that there's much there to rotate. Okay. Does that make sense to everybody? Okay.
When you say bugs or birds and all that flying around, you're talking about flocks of birds, right? Not 2, 3 hanging around there, right?
Right. Yeah.
Okay. And bugs, we're in trouble if we see that many bugs.
Well, but yeah, swarms of bugs will show up on radar.
Yeah.
And it could be trees, it could be, you know, I mean, that's the other thing. I just keep saying bugs and birds because I like the way it sounds, but you know, it's debris. It's the official term you might see is non-meteorological targets. You know, so it could be trees, it could be leaves, it could be, there's all sorts of things it could be.
Right.
Okay. What is it? Why is it an issue and how to account for it? I think I sort of touched on all that. And here's a good picture that shows it. You know, the radar is shooting out its main lobe here, but then it's got side lobes on you know, a couple of side lobes. It's got more than that, but a couple of side lobes. So this side lobe is actually hitting the anvil of the storm. Okay, so that rotation that it's telling you is there is actually coming from the anvil, which is like, that's not a tornado, you know? So the radar thinks it's seeing the main lobe, okay, and it says, okay, I've got rotation there, you know, and it comes back to the radar and says, this is rotation, but it's not. Does that make sense? I know this might be tough, I'm trying to make it so it's not too complicated. So,
Does the load change position, with the horizontal or the vertical polarity?
No, it's a parabolic, it's a dish, so. it's-
Okay.
Yeah.
Okay.
So here's just, you know, I mean, you got the main lobe and then you got all these side lobes. I grabbed this from something else, that's for Yagi antenna. Yagi's antennas also have the side lobes. Side lobes are usually good things though, because you hear people that you normally
Very
wouldn't
good
hear.
thing, except my rotor's not turning anymore.
Yeah,
Anyway, get out.
The really bad things if you try to talk to a satellite.
you know, satellite light isn't here today, and a flat tire. Anyway. So anyway, so here's another good example. Hopefully this is a good example. You can see, if you look here down south of Derryville, there's a little square there. Okay. You look at the reflectivity, there's nothing there. Okay. You look at the velocity scan and it looks like there's something happening there. But it's a side lobe. And you know that because there's reflectivity isn't there, the correlation coefficient doesn't look right, you know. I mean, all this stuff is just not right. So,
To wonder anybody can actually figure this all out on the fly, but
it's hard. It's real hard.
Do they usually look at the raw data, the meteorologist, I mean, rather than the process in the level 2?
Well, nobody looks at level 1. Level 1 is just
Too mess.
Yeah, right. Yeah. So you look at level 2, and level 2, you know, I mean, they produce level 2 pretty quickly. So that shows you basically what you want to do. And you need at least level 2 to get the dual pole stuff, you know, because otherwise all you just get is blah. So.
well, have you ever heard of anybody using helical antennas instead of the dishes? There's a little bit lower gains, but they suffer from side lobes so much. You know, regular ones that.
Yeah, I don't know that anybody's using that for real.
You know,
Get the gain on it?
that's the problem, that's the trade.
That would be circular code.
Yeah, but yeah, it's true surfing, so, yeah, but it's a lot less side lobes.
So one of the things that they do is they actually will sort of, and they get trained on this, and so they sort of mentally do this checklist, you know, and they want to see basically everything look clean in their checklist. And in this case, the rotation is, and remember I said that they're doing these volume scans, so they're doing scans of various altitudes. If there's rotation in one scan and then not in another scan and then in another scan and not in another scan, it's like, okay, that's not really rotation. You know.
Now, you mentioned rain and hail. What about snow? Snow is bad news, right?
Well, snow.
Too much water.
Well, snow is ice crystals, basically. So they all, and I'm not going to go through it in detail or what all the different signatures are, but you can see one of the things you'll see is like in reflectivity, snow tends to be more diffuse. Okay, so that's one of your clues. The correlation coefficient is going to be different. And that, again, that depends on how high up you are. Because when you're up real high, they have these dendrites, is what they call them, which are the needles and all the other things. So they're going to look different on correlation coefficient than, you know, than a raindrop is going to look. You know, so there's all of those things that you're looking at. And I'm not going to go, I mean, that would be days of which I can do.
If on top of all of this, you have very high winds, that also must screw things.
Oh, yeah. But so anyway, you look at this, is there a tornado there or is there not a tornado? You know, well, you gotta look at all this stuff, so, the quick answer is there's actually both in this picture. Okay, so and I know there are two different color circles, but I don't know which is which, but the lighter colored circle is not a tornado. Okay, and even though you have the high correlation the low correlation coefficient. Okay, you don't have anything on velocity and you don't have anything on not really much of anything on the reflectivity. So this upper left one is the reflectivity. And you can see that there's really not much there, just light stuff. Even though it looks like there's rotation, if you look at the lower left, lower right, which is up a little bit higher, there's nothing there, so it's not consistent across all multiple scans. All those things are the clues, and like somebody said, you know, it takes some time. It actually takes experience, because once you have the experience, you can look at all this stuff really quickly and come up with an answer. But I mean, that's one of these guys that are working the radar, they're sitting there going, and they have to decide real quickly if they're going to put out a warning or not. Yeah. So. Tornado debris signature, I sort of touched on this. If the correlation coefficient is real low and it's right where the rotation is, then that's debris that's being picked up by a tornado. Okay, they will actually confirm tornado based on a TDS, a tornado debris signature. And you can see it right there. You can see right here. You can see some of the blues in there, so that's debris. It's right where the rotation is, and there's really strong reflectivity there. So all four of those together is telling you that basically there's a tornado.
There must be another measurement too, but you probably need a lot of sensors, which is like local velocity, right? If I had a grid of velocity measuring anemometers, right?
Yeah.
I should be able to see rotations and speeds and all that, but that's way too many sensors.
Yeah, measurements do exist, but not. There never seems to be a measurement where you need that's determined as a measurement. So. Okay. Yeah, this is the July 29, 2021, which is the big outbreak I was talking about. And on here, you actually see a TDS, you see low correlation coefficient, which is actually due to hail, again, because you have these big pieces of hail and they're not uniform, because when hail gets big, it gets real spiky and that kind of stuff. So the correlation coefficient goes down. And then you also have side lobe contamination. So if you look here at the lower circle, there's what looks like low correlation coefficient with no reflectivity. That's side lobe. Yeah. You see low correlation coefficient with really, really high reflectivity. So that's hail. Okay. And then you see an actual area where there's low correlation coefficient, and we don't have do we have it? I don't think we have it, but the rotation was actually really strong on this. This is where that the car dealer is. Yeah, it's going to come. It is going to come. So anyway, so I mean, they're actually sort of sorting through all of this, and this was a big mess with that because of the side lobe and the big hail and everything else. They had to sort all that out. So they actually did not get the warning out real early on this one. Faulkner car dealer. Yeah. Told you it would come to me. Okay. Now this is a downburst, and downburst, sometimes people think that it's actually rotation. But the trick with this downburst, you can see there's the greens and right next to the reds. If you look, here's the radar. So this wind here is actually moving. Yeah, moving towards the radar. The green is towards the radar. And then the red is actually moving away from the radar. So you actually have a downburst wind go like this, which they do. So even though you would look at that and go, I think it's rotation, it's not. Because this, you know, this is where the radar is. So the radar isn't going to show you rotation unless you turn this 90 degrees, then it's rotation.
Do you ever have cooperating radar, especially in high density metropolitan areas, like two radars close together?
Well, yeah, in a lot of cases they do. In fact, we keep talking about the Fort Dix radar. Okay, there's also another one at Dover. There's the terminal Doppler, which is the Philadelphia terminal Doppler. And then I know they're gonna start using Millersville at some point. So, you know, they will be able to get some really good triangulation and stuff. And in fact,
I'll be a problem like this, where you have to,
Yeah.
Yeah.
the Doppler on wheels, the downs that I was talking about, they actually do that. They're all at different angles to the storm. They're getting really good cross sections. Yeah. All right, I'll probably keep talking until somebody tells me to shut up. So.
Very interesting.
Yeah. Satellite stuff, I'm not gonna go through this in detail, but basically, recently they put up these brand new satellites, and these brand new satellites now get, they can get pictures more often. They can get higher resolution pictures. And one of the things they can do is, if somebody wants it, so like when a hurricane comes through, they can actually zoom in on where the hurricane is and get you pictures every minute. So they get really cool pictures.
The original satellites were on, they weren't geostationary, but they were also on 137 megahertz.
Right.
So you can actually get refax pictures and all that. So if you really want to get it, you better hurry, because sometimes you should shut it down.
There are still polar orbiting satellites. A lot of the stuff you get from a hurricane.
That's what the original VHF ones, like 137.
A lot of what you get for hurricanes and stuff is actually from, they call them POEs or polar orbiting ones. And so basically they're just doing splices as the Earth spins underneath them. Or if you believe in the flat Earth.
Well, they depend on the. Or
Yeah.
sometimes they stay,
Right.
but most of the time it's always rotating.
Mhm.
So the Earth's rotating and the almost rotating.
Yeah.
So
But basically, when you look at those plots, they're actually slices.
it always slices.
Yeah.
But the other thing is, for the lower polar ones, lower and polar,
Mhm.
you get better resolution. I don't know how important that is.
Well, I mean, it's real important. In fact, some of them actually,
Because geo, you don't get the best resolution.
right, the geostationary ones are basically just out there receiving data. The polar ones, some of them are fitted with transmitters too. So they will actually transmit.
So it's, you're not taking the image from the geosynchronous, you're basically using it as a relay.
Probably didn't say it right. The polar ones will actually, they have instruments that will do similar to what the radar does. They will actually point down at the, you know, like for the hurricanes, they actually will measure how high the waves are and that kind of stuff. There's all, but that requires them to actually do the transmits. So,
But what I heard you say was that the polar satellites send messages to the geos.
no,
Oh, I'm sorry.
the polar satellite, a lot of these lower orbiting satellites have both their recording, their instrumentation includes something that transmits, whether it's a radar or whether it's something else.
Wouldn't be much use.
No, well, it's actually a lot of use.
So I said it wouldn't be used if it didn't transmit.
No, well, no.
Because
They all,
the data stays
they all
inside.
transmit the data back to somewhere, but I'm talking about actually the instruments themselves include transmitters so that.
Oh, okay.
So that they can get different kinds of information.
Get reflections back.
Right, yeah,
But the ones that are high up in geostationary are just sending pictures. back.
right.
They're
Their
not-
instruments are all receivers and then they transmit the data.
But the problem you have is at that altitude, which is, over 20,000 miles. You lose resolution.
Mhm. Yep.
I mean, can't beat land over D.
So like the first satellite was a Tyros satellite. You probably worked on those, didn't you?
I
But
didn't,
that's what the resolution looked like on the Tyros.
He told you, if he
But
did,
now,
he told you, he'd have to kill you.
what's that?
If he did, and he told you, he'd have to kill us all.
But this is like the latest versions of GOES satellites, geostationary satellites. This is the resolution you can get from them. And again, they can actually hone in on certain areas and get really even higher resolution.
Is any of that optical, other than, the basic optics to get the field of view that they want on the section of the Earth? Or are there actually lenses in there that are changing in and out or zooming in and out? Or is it all like a digital zoom kind of thing?
I don't.
Yeah,
I'm guessing that's a lot of digital stuff,
Yeah.
but
yeah,
I'm not sure.
well, it's all digital at that range.
Yeah.
They just put an iPhone 16 on.
Yeah.
yeah.
But the GOES satellites actually have like 16 channels receiving various wavelengths of stuff. Okay, so like these here are more visible, and then you get down to here and it's more the infrared stuff, that kind of stuff. So there's also a lot of ways that they put that data together to get pretty pictures. Okay, it also has a receiver that receives lightning flashes, the GLM.
So
So
the problem is that the resolution is proportional to the diameter of the dish. So. You just. I mean, if you put a bigger dish on, you'll get a better resolution.
Yeah.
That's just physics.
mhm. So anyway, it can register lightning. Let's see, is this? Okay, but depending on how those 16 bands, depending on how you merge them together, you can get different things. They got the natural color band, which is one thing. There's the daytime cloud phase. So like these, the different colors tell you whether it's a high cloud, low cloud, fog, whatever it is. Nighttime microphysics, that's one of my favorites, because one of the things you can see in nighttime microphysics, no sun anywhere, you can see fog. Okay. It combines a couple of bands together, and like this is all fog in the valleys around Pennsylvania. Okay. That's one of my favorites.
Light pollution doesn't affect it. I guess they're looking at the IR range.
Yeah, well, that's nighttime. So anyway, that's the GLM. The lightning monitor. Those are actually all thunderstorms.
What
Or
the flashes are.
the flashes of the lightning, yes.
So
It was like a whale.
is that actually data that the media outlets are buying from these satellites?
Say that again.
Because they have, there's like high number of lightnings. Okay, whatever you'll say, high number of lightning strikes in Chester County. Is that basically
Well,
this data?
this is basically just from above, can you
Yeah.
see the lightning?
Yeah.
A lot of this lightning never makes it to the ground.
Okay,
A lot of it just stays up in the anvil or.
because they often say ground light or.
Yeah, there are actually lightning detectors all over the place
Oh,
that are getting.
so that's more of the source for.
Yeah,
This is just optical
Yeah.
images of the lightning.
Yeah, Florida especially.
Yeah. I mean, it's just,
Check it out.
if you think about it, that's how much lightning happens in these things. We probably only see a small fraction of it.
Good.
I think you hear it if you go down on the AM band.
Yeah.
And this is just another thing, as the thunderstorm got up higher, they changed the color scheme on it, you know. Based on what they're receiving, they know that it's up higher, so it's a different color, so. Those are all the things they can do with satellite. There's a big, big old, what is it? What's that? It's it's not really a hurricane, it's up too far north to be a hurricane. It's up by Greenland, isn't it? No, it's still part of, Denmark.
For the next week or two.
Yeah, great.
Hear what you said.
There you go, that's,
Good Air Force Base.
See the submarine base there, Jim?
there's actually a lot of text here, which I'm not gonna read, but it's basically, there was both snow and thunderstorms and everything else that came out of this thing. There you go, there's some more of the lightning, but that's algae, tropical cyclone. See, is that? That's tropical cyclone Elsa. Yes. Again, I said that they can sort of home in on a certain place. Mesoanalysis is analysis on a smaller scale. So the satellites can help with that. Fire detection, everybody. Can you see the fire in that picture? It's a little bit hard to see. Yeah, right there. Yeah.
So do the guys in the weather offices and the weather observation centers fight over who gets to look at radar, and who gets to look at satellite data?
Yeah, that all gets assigned to them on a daily basis.
So it is a thing.
See this one here, this big fire here, that was a big fire in Colorado a little while ago. See all that smoke coming off? Yeah, you can see that pretty easily. And depending on what they're looking at, they can actually see, they can see the fire, they can see the smoke. Like if you see this on radar, you'll see a really low correlation coefficient because it's not preset, it's actually smoke. That actually happened a number of years ago. Kate Bilo actually got all excited because she saw this big long streamer and she thought it was snow. But it was actually smoke. It's like, you gotta look at the correlation coefficient, Kate. She said, okay. What's that? Yeah, well, no, it was cold enough to be snow.
What's that sweeping, what actually to me looks kind of brown,
Okay.
right there, it's coming.
You're talking about this here?
Yeah,
That's what this slide is for. Very good.
okay.
Yeah, it's called a haboob. Somebody ever heard the term haboob? Somebody was.
It's a science form.
It's the, yeah, you were in Africa, you've heard of haboobs, right? Yeah,
Okay.
they were basically big dust storms.
Okay.
Okay, so that's a big dust storm that comes sweeping out of Colorado.
For the sands, yeah. Colorado sands, right?
Yeah. Comes out of Colorado, goes through the Oklahoma Panhandle into Texas. They show up on radar too. I don't have a good radar shot of that. All right, does anybody know what this is?
Chesapeake Bay?
What's that? Well, it's a Chesapeake Bay, right? Or is that the Delaware Bay? It's a Delaware,
Yeah.
Delaware Bay. But look real closely at what's happening with this stuff here. It's ice. Yeah, it's ice. It's not solid ice, so it's actually, as the tides come in and out, the ice is moving back and forth.
Oh, you're talking about that lighter, okay,
Yeah, along the Jersey Shore.
okay.
Or not the Jersey Shore, but the Jersey Gulf.
Yeah.
Gulf of America.
Gulf of America, there you go.
Oh, we didn't survive.
All right, does anybody know what this is?
United States.
See anything happening there? So watch it closely. Look from the, see that right there?
Eclipse.
That's the eclipse. Yeah.
Oh, yeah.
That's the 2017 eclipse.
Oh.
Okay. Which, you know, I don't know if anybody went out in 2017 to look at it. You know, Dick's not here tonight, but Dick actually took a string car out there.
Yeah, put glasses on.
Yeah. All right, now this one I gotta hit here. There you go. There's another eclipse, right? That was fun, that was last year.
That's last year, yeah.
See it? Okay,
Is that taken from, the Geo?
I believe it was, yes. It's in there.
I can't read that.
It says geostationary and it says geocolor, so it's one of those things where they mix the different frequency bands together, they get geocolor. Which is, you know, the ground's supposed to look more natural when they mix them together. Like that.
Most of us can't see in the expand.
Okay, so soundings, hey, you still okay to keep going or do we have to wrap it up? Okay, all right. All right, so what happens is, you've heard of weather balloons, everyone's heard of weather balloons. They send up a weather balloon. What do they get from the weather balloon? They get temperature, dew point, wind speed, wind direction, and barometric pressure. Those 5 parameters, they actually plot on the chart. Okay, and that's called, setting the balloon up is called a sound. Plotting it on the chart, there's different charts you can use. The one that most meteorologists use is something called a skew-T chart. Okay, so I'll show you the skew-T chart. The reason they call it skew-T, anybody have any idea? You know what the T stands for, right? Temperature, right? Okay, well, if you look at the skew-T chart, like that's the 10°C line. So it's not straight up and down, it's actually tilted. So that's why they call it skew-T chart. There's a bunch of other lines on there. There's moisture lines, there's mixing ratio lines, there's a whole bunch of stuff. You don't have to worry about too much of that. But the parameters that you get from the balloon are actually plotted on here. So let's see. This is your temperature line. Okay, this is your dew point line. I put arrows here to point to them. So your dew point, which is your moisture, is always going to be either below or at the temperature. Because that's the way it works, okay? The other thing that I put there is what's called a parcel line. I don't know if from the basic Skywarn, we talk about instability. Everybody remember instability? Okay, well, when the air is very unstable, you will see a parcel line that looks like this. It's all the way over on this side. Okay. But you can see down here, it goes actually, the temperature goes above the parcel line, and up here, the temperature goes above it. I mean, below it, sorry. Above it, yeah. Okay, so the parcel line is telling you, like, if air starts rising and it gets to here, it's gonna keep rising. Remember the instability, if it's, and it's all, it really is mostly to do with temperature. There's a little moisture involved as well, but basically hot air rises. Okay, so if I'm a parcel of air and I'm rising and I'm warmer than everything around me, I'm going to keep rising. Okay, so that's one of the things you can get from a skew-T chart. You can get a ton of stuff from the skew-T chart. Just basically from those 5 parameters that you get from the balloon, you can get a ton of information. And some of it's listed here. I don't expect you to understand what all these acronyms are and everything, but let's see. Well, you know, so you get latitude, longitude, equilibrium layer. level, equilibrium level. Freezing level, there you go, freezing level is at 603. So your freezing level. Better from the other side. So your freezing level, you see where your zero line is? Here's your zero line, right? Your freezing level is where the temperature line crosses the zero line. So this temperature line is going up like this, where it crosses the zero line, that's your freezing level, basically. Okay, so this will tell you where the freezing level is, a whole bunch of stuff.
That's all Celsius.
Yeah, these things are all Celsius numbers, yes.
What do these rockets on?
Say that again?
The rockets, they send up rockets on?
Well, I mean, yeah, there's all sorts of different ways to get soundings.
Yeah.
You know, balloons are the most common ways, but yeah,
Yes.
the hurricane hunters, they actually do drop signs. Drop signs, they actually drop a sounding instrument out of the plane and it goes down.
Oh, okay.
You know, all different ways to get soundings, but they're still just basically producing those five things.
Okay.
But that's the thing, it's like, so if you remember from the basic Skywarn, I used the word Skywarn. Oh, yeah. The more unstable it is, the more vertical motion you're gonna see, okay? This parcel line, if it's real far away from the temperature line, that's telling me it's more unstable. If it's real close to the temperature line, it's not it's a little unstable, but not super unstable. And of course, if it's below the temperature line, it's not unstable.
These things basically have to rush out and pick a good spot that we got the point off.
Yeah, like, yeah. And I think technically you have to get FAA approval.
Do they do those from the same place almost all the time, release?
Well, the official soundings always happen in the same place. There's 70 some places around the US.
Oh, so that's only that you.
The closest one to here, I believe, is.
One's Villanova, isn't it?
What's that?
The Villanova Science Club, will they run that?
Yeah, but that's not every day. I mean,
No.
The cycle for standard soundings is twice a day. At zero UTC and 12 UTC. So that's morning and evening.
Isn't there, seem to remember, please go back and read about, I think it's in Florida. There's a balloon on like a 60-mile long cable or something, 20-mile long cable.
I'm trying not to fly into it.
Yeah, right.
Well, that's been a problem.
I-
Well, no, I'm not making this up.
No, I didn't,
Yeah. Yeah, they don't think, I don't know that that's used regularly, but, you know. I mean, from those 70-ish locations, they basically, when you see upper air charts, so you'll see on TV, you'll see, oh, here's the jet stream. It's basically an upper air chart, it's a little idealized, but it's basically an upper air chart. That mostly comes from soundings. They also get some of it from satellites as well.
Did they try to get the instrumentation packages back?
Well, they don't expect them back, they actually have a return address on them, so occasionally we'll get them back.
It's shipped by FedEx, so.
Yeah. Oh, never get it.
Hey, Prime will deliver it.
So anyway, any more questions about this? I mean, I spent weeks studying these things in class, you know.
That's mine.
Yeah.
But-
This is below moon, okay.
Yeah.
Yeah, you were saying, right? That's
Yeah.
why it's called. But for hands do this too, it's not only just a package, it puts the APRS on it.
Yeah.
Right.
But yeah, and that's the thing is that. These are just some of the instruments that we have. We have radar, we have satellite, we have balloons.
What's coming?
What's that?
What's coming in the
Well-
next 10 years or so?
Well, I don't know if it's 10 years, but one of the things that they're working on, which they've been working on for decades, is space array radar. He's not a yes, it is what makes it regular. It's basically, rather than this big dish that's spinning around, it's actually a bunch of little radars. And basically they all just fire.
I can see on the story.
They Starlink satellite.
Yeah, well, the Aegis system, actually worked at a company that's doing Aegis.
You ever go down the New Jersey Turnpike, you see the Cornfield Cruiser, which I think is still there. That's the flying bridge in the Aegis. But the interesting thing from a ham point of view is, it's the USCRCA missile surface radar, and he was there as a student. And before they put the ecosystem, the flying bridge there, there was actually a golf ball, it was a geodesic dome, which was one of the units of the beaming system, listed as the missile early warning system, the one that we used to have a bunch of these things across Alaska, Canada, and actually in Greenland too. So, right. Beaming system got decommissioned when they had satellites, so they took that down.
Oh, here it is. Yeah, I was mistaken. It says here, it's tethered aerostat radar system in Florida. And it's located in Cudjoe Key. And the balloon contains radar that can detect aircraft up to 200 miles away. And in 2007, a private plane crashed into the cable.
Yeah,
So I was agreeing, that's good.
okay. And how high is it?
I just get it right. I don't know, it's miles.
Yeah. Yeah, I used to work with a guy named Dennis. All right, so anyway, so this here. Okay, I'm not gonna talk about this slide too much. Basically, there's a bunch of thunderstorms going through here. Okay. Mostly with straight line winds. There was one tornado, which I'm not gonna see on here, so. Okay, so. One of the things that you're doing when you're doing a weather forecast is you're looking at weather maps, basically, okay? This is your surface map. Your surface map. Everybody knows what cold front is and a warm front and that kind of stuff. The triangles are cold fronts, these semicircles, those are warm fronts. So that means that the air on this side, so just below where the semicircles are, that's warmer air. Here, just above where those triangles are, it's colder air. So that's what it's telling you. And a whole bunch of other stuff on there, but basically the important thing there is that there's stuff happening around Pennsylvania. You can see it. You can see there's a cold front there. There's yeah. What's that?
In July.
In July.
How cold?
Not cold. Let's see, what are some of the temperatures? The temperatures are here. And let's see what the time here is 128 Z, so that's like close to like what, 9?
Yeah.
July be 4 hours.
Yeah. All right. So you can see like there's 77, there's 74,
Oh, okay.
72.
cold front?
Well, yeah, see, on this side of the cold front, you have 81. On this side, you have 72, so,
Okay.
yeah.
So which is the cold side of the one that has the triangles or the one that
The side, this is the cold, if you look at this one here,
yeah,
this is the cold side, this is the warm side.
okay, so the
Give me fingerprints all over your TV, sorry.
the triangles point away from the cold.
The triangles and the circles both are pointing in the direction that the front is moving.
Oh, it's a velocity.
Well, it's not really a velocity, but it's a motion, but not, yeah. Right, so you can see these circles are on that side of the line, so the warm air is moving this way, see that right there? Yeah. This one here is what they call a stationary front, which is why you see the circles and triangles on both sides. It means it's not moving much.
No, I heard a lot of parameters being measured, maybe on the balloon sound link, barometric pressure, it's gotta be one of the parameters.
Yeah.
Right.
Calibrate that before it leaves?
What's that?
Did we calibrate that before, like what's the current ground level or sea level? air level
That's
pressure?
that's for the altimeters.
Yeah.
Yeah, well, and basically they use the pressure that's recorded to basically figure out the altitude. That the balloon is at, basically.
But so they do take the time to calibrate it at ground.
I would hope so.
Yeah.
Outside, it wouldn't be much.
It wouldn't, right.
Right.
It's not calibrated.
Well, yeah,
Yeah,
I
sure,
just
it's
with
still
weather
there.
data collection, I didn't know if it might just be relevant.
So from those like 70-some balloons that they put up, they were able to figure out that there's a trough. This is, what is this? This is 300 millibars, so it's way up. Okay, so 300 millibars, you have a trough, which is usually symbolized by that. You have a ridge here, big old ridge there. You can get the wind, you can see the winds that are moving. It's got a couple other things on it, but that's, again, that's from, mostly from the balloons, a little bit from the satellites. So you can see there's a trough in the east. Which when you see bad weather, you're usually looking for a trough. Oh, they actually marked them, look at that. So that, when they do that, sawtooth line, that's a ridge. Okay, and when they do the dash lines like they have up there around Pennsylvania, that's a trough. And remember we talked about sounding, so. Is this air very unstable, slightly unstable?
Not at all.
Not at all, who said not at all? It's actually pretty, it's pretty unstable and it's pretty unstable up pretty high. So on this one, which is OKX is New York, right? I think that's New York. KIAD is Dulles. Okay, so it's not real unstable around Dulles, it's more unstable up around New York. Okay, as you can see, it's wider here. See, this is wider. That's more narrow. They both have some instability. 1247 Cape is one of the ways you measure instability. 1247 is for around here, especially, that's pretty high. 726 is also high, but it's not super high.
Right.
Yeah.
How come you can't tell when it's gonna rain tomorrow?
They don't prediction, they'll give you the option.
Right. From that, have the outdoor weather's.
It's supposed to be 9 degrees warmer.
No.
Wow.
Yeah, and if I wanted to, I could bring up like what the current surface chart looks like. But basically, there's a warm front and a cold front. We're basically gonna be in the area that's the warm front. Between the warm front and the cold front, so that's where the warmer area. Do you want to try and answer the questions? Do you think severe weather is occurring in this picture here?
See a line of thunders.
There's a line of thunderstorms. One of the places that caught my eye real quick is how strong the reflectivity is there. So there might be hail. I don't see anything there that screams,
That gray over New Jersey, is that just like scatter from the time of day? I know
Yeah,
it's
yeah,
part of the
yeah,
radars
that's-
that get this-
I mentioned anomalous propagation way back when, yeah, so that's pretty much, I if we look, do we have the correlation coefficient? Yeah, see, the correlation coefficient really sort of helps you with that. See how mishmashy that is? That means it's not really preset, So anyway, let me go back again.
I see that every day.
Yeah, pretty much. All right, so this is the velocity scan. Which velocity? This is, I can't tell which one. But do you see any rotation there? You see any strong winds? Not really. This is,
This is gonna be a trick question.
but the thing is, you see stuff here. Remember, I saw that really strong reflectivity and said, I think that might be hail. I think, I'm trying to figure out what this is. This the bill? I can't remember what this is. Let me see what this is. Sorry. Okay, I can't tell, but basically just looking at this. Something's happening here and something's happening there. Isn't that so?
Because urban oceans are not really that concerned, they just blank the data so that people don't get confused.
Say that again?
All of the ocean areas are basically clear, right? Like, do they just blank the data?
No, I mean, if there was something out there, it would show up on radar. See?
Out to the range of the radar, right?
Yeah, well, I mean, that radar's, Fort Dix is actually pretty close to the ocean, so it's just. So there's your correlation coefficient, that one I know for sure. You can see a lower area of correlation coefficient there, which remember I said if it's big hail, a lot of times your correlation coefficient is lower. So I'm pretty much thinking there's hail right there. Okay. There's something happening there, but I think that is out of the range of the radar. So. All right, so this is the cell up by Perth Amboy, up in your neck of the woods. So what do you see there? And this is from the Fort Dix radar. Again, you see pretty high reflectivity there. What else do you see? Is it a squall line? You see any kinks in the squall line? Maybe. Okay, that's a base velocity. Okay. See anything interesting in the base velocity? Maybe like right here? What, this white line here?
No, the fluffy ones, it looks like
Yeah.
clouds.
Right.
This up here?
Yeah.
Yeah, remember, this is velocity, so whatever it's seeing, there's like weak velocity in it, but to me, and again, since I'm colorblind, I might have this totally wrong, but there's some reds here, and I think there's some greens here, so there might be rotation there. Not super strong, but looks like there might be. What's that?
They say that looks like there might be more, or stronger.
Yeah. Now they switched to the TEWR, which is Terminal Doppler at Newark Airport. And I think it's actually too close to the radar to really see much of anything, honestly. Yeah, look at how close that is to the radar. That's not really going to show you a whole lot. It looks like there might be reds and greens. Said there was a funnel cloud reported there, but no tornado. Okay. There is a tornado here. Can anybody figure out what the tornado is? This is reflectivity, so you're not going to see rotation. So do you see a hook echo? Do you see squall line with the little peaks in the line, any of that kind of stuff? And I don't see much there.
What's down on the lower left?
What you talking about? This here?
Up a little higher, you're right. Down, right. Right, the other way. Down. Is. The yellow thing is called.
Those are not real strong echoes, so I would question that, but. we'll
I
find
don't
out.
have no idea.
Yeah.
Look for certain.
Okay, all right, does this show you any rotation?
The one over by Wadestown or? It's that drastic green change.
I think whoever said Greatstown is the winner.
Point roads, straight down.
Let's go back.
There.
Why does it look like an explosion?
That's what the radar is, right? Yeah.
Yeah,
You know,
it's
it
just that together.
There you go. Well, the first, see, that was base velocity, okay, which is if a storm's moving real fast, you see really bizarre looking things sometimes in the base velocity. So if you go to the storm relative velocity, remember I mentioned those two different kinds? You see anything with red's right next to greens? There's your greens there, there's your reds there. And where's the radar? The radar's here. So yeah, so that all makes sense. If the radar was up here, then you would say it was straight line winds. Radar's down here, so you're saying it looks like rotation. Get my exercise. Right. There's also a lot of rain, so a lot of flooding happened. That's how much rain fell. Again, these color coded things, but there were a couple inches, 3 inches of rain in spots. So there's the actual reports, and I can never find the tornado reports in these lots. But it should be right near Wrightstown, right? That's hail, right? Is that the right color for hail?
Can't see it, you.
Yeah. Yeah, I'm not good at this.
Where do those reports come from?
Well, they come from various places. Some of it is from spotters. Some of it is from, if they see a TDS on radar, they're gonna call it a tornado. Yeah. So it was one hail report, one tornado, 35 wind reports. So, yeah. November 15, 2028, 2018. Somebody. This one, okay. Pretty much done. This was my view over the 2024.
Well, you.
You're welcome. All right, you can't leave. There you go. So we've answered probably everybody's questions, right? Anybody have any other questions?
We're making progress with weather analysis, prediction.
Well, hey, yes, we are. The part of the problem is, we have all these weather models out there now. A lot of people are relying on the models maybe more than they should.
Yeah, why didn't it show like the hurricane tracks that show like 9 different models?
Well, because there's all these different models, and they never agree. So one of the things they're doing with the models is they're trying to see where most of them are going.
Why the hell do we need a European model for Atlantic hurricanes in Florida?
Well,
It's not hurricane data, it's
What's that?
hurricane model. I mean,
Yeah.
it's not a hurricane data.
they're all using the same data.
Yeah.
Model.
And then it's who developed the model. Europe was developed by the Europeans. You have a couple of Canadian models, you have a couple of American models. One of the things, and obviously not part of the presentation, but one of the things that they should be looking at, and maybe they don't look at as much as they should, is what they call the symbols. There are basically like the Euro model, right? They take the Euro model and they take all the data, fit it in, and they produce a plot. Okay, well then they say, well, what if this data wasn't quite correct? So they tweak it a little bit. and then they run it again.
There you go.
Okay, and if all the ensembles agree, then it's a pretty good forecast.
Right.
If the ensembles end up being all over the place, then it's, you know, that what happened your first run is not necessarily the best.
You didn't tickle it in the right direction.
No, you don't know. Sometimes you throw in the data you don't want, you get the data you want.
Yeah.
May or may not be.
And you've done that? Sure.
Okay,
Are you done?
yeah, I'm done. And don't click on that QR. That's the Skyward QR. That's basically once, I'll send it out to people. Once they allow us to do Skyward again, I'll send out this link to people. And then you can request a certificate. The Weather Service no longer issues spotter IDs. And they don't send out certificates unless you ask for it. So,
You've been done last time.
that's that, yeah,
We got our certificates.
yeah. Oh, they did send it, that's good.
Why is there Barney the dinosaur?
Cause the program that's free. I generated that QR code myself, so. So anyway, so yeah, at some point I'll send them down to people and say, I have a request, you should do this.
Thank you.
Always a great presentation, and you have a question there.
No, not for, totally different subject.
Uh-oh.
I apologize for being late. There will be a PE session this Saturday. We have one person signed up, presently. I need to get more than last minute. So any of you who are present, please try to do a Saturday, of course. I will send an email. If not this evening, then tomorrow. Very much.
Someday I'll finish the actual test that says you can become a VE, but I've never actually finished it.
It's open close.
Yeah, I know.
Brian. Everybody has to take a cookie on the way home, because I don't
Same
want to take
test
them
of
home.
the
Help yourselves,
NFL
please.
referees.
Take a cookie.
A cookie.
A whole box.
Sorry, was it?
Same test as the NFL referees.
Yeah, right, yeah.
All right, well, that will conclude the meeting.
Yeah, let's go. Yeah, let's be a referee.
You see, we had to go in.
Yeah, that's fine.
Jeremy, you still there?
Yes, I'm here.
Okay,
We're done.
the meeting